Hello students, welcome to this 21st lecture session of the course Database Management Systems. In this session, we discuss about database tuning. We look at what is database tuning, what is its importance, and what are the various approaches for database tuning. And we understood that in designing the whole database system, we have conceptual database design, logical database design phase, and then physical database design phase. And in the physical database design phase, we actually take decisions regarding the indexing structures that need to be used for fast retrieval of the records and the partitions that need to be made to speed up the execution of the queries. Okay, so conveniently storing the data. Like this, we take decisions regarding how actually we store the data on the physical disk. This plays a significant role with respect to performance. And the factors that affect physical database design are: we need to clearly analyze the database queries and then transactions for understanding what files they are trying to access for execution, what are the attributes that are part of the queries and that are used in the selection, what are the selection condition types, and what are the join attributes used, and what attributes are required into the result. All these are necessary. Similarly, for update operations as well, we need to clearly analyze and then understand the requirements. Then we also clearly understand what is the frequency of executing these queries and transactions, and we need to understand the time constraints associated with queries and the transaction. That means, are there any time constraints? That is, what should be the response time for this kind of query or transaction? Do we have any such kind of constraints on that? That we need to understand. Then we also understand the frequency at which the update requests are executed, and we analyze the uniqueness constraint on the attributes. If we have clear idea about this, the physical database design becomes more and more easy and then effective. And coming to the physical database design decisions, we need to take decisions about the indexing. That is a very important, significant task. And with respect to the indexes, we need to decide upon whether a given attribute, on a given attribute, we need to construct an index or not. Key or attribute used in the selection or join condition. And what attribute or attributes need to be indexed. That means, if the retrieval of the records is not based on one attribute condition, if it is on multiple attributes, then do we need to construct index which involves multiple attributes? And whether to set up a cluster index where the range queries become easy and then faster. That means, if we construct cluster indexes, all the tuples which have that similar value, they fall in the same cluster. At the same time, whether to use hash index or the tree index, that is the B plus trees. If I am using hash indexes, it will not support the range queries. It will support only the equality queries. And if I use B plus trees, the advantage with B plus trees is it will support both range queries as well as the equality condition. We need to take a decision on that as well, depending on the requirement. And lastly, we need to take decisions regarding whether to go with dynamic hashing if it is hashing, and if we go with hashing technique, whether to use dynamic hashing or static hashing, because the static hashing is more suitable for files which are static in nature, meaning that they don't grow or shrink over the period. Okay, and if a file grows or shrinks and then it is not static in nature, that is when it is dynamic, the number of tuples or the records or the file size grows or decreases or shrinks, then better to go with the dynamic hashing techniques like linear hashing or extendable hashing, so on and so forth. We need to take these kind of decisions with respect to indexing and hashing. Now let us see what is database tuning. revising the physical database design decisions after the deployment based on the actual statistics about the usage of applications, queries, transactions, and views that are created for the applications. And this process is known as database tuning. So the initial database design, after the conceptual database design, we will do logical database design. We will perform the physical database design. That is done in the beginning itself. Okay. And initially, depending on the requirements, we assess certain things and then we construct the indexes and then we perform the partitioning of the tables, clustering of the tables, so on and so forth in the beginning before the deployment. Okay. Now the application is deployed and the database system is in use. After the deployment, we closely observe the application for its performance requirements. And based on the statistics actually collected, depending on the query execution, transaction execution, and all these things, we revise the decisions we have made with respect to physical database design. That is with respect to normalization or with respect to indexing, partitioning, and all these things. So this is known as the database tuning process activity. Hence, the database tuning happens only after the system is deployed. And once it is deployed, we will observe the system and collect actual statistics with respect to the application and then query execution for certain amount of time, and then we analyze it and then we change our decisions with respect to physical database design. That is database tuning. So what is the purpose or goal of this database tuning activity? To make applications run faster. The ultimate goal is to improve the performance, to lower the response time for queries and then transactions, ultimately which leads to improved overall throughput of the system. This is the goal of this database tuning activity. Okay, what are the tuning options? That is the approaches for database tuning. First, we will look at tuning the indexes. That is, we will revise our decisions with respect to indexing structures. And sometimes what happens is, in the beginning, while doing this physical database design, with an assumption or with a assessment, we might have constructed some indexes on some attributes, and then later we may come to know that these indexing structures are not actually used by the application or the queries. They are not required, and if I maintain those indexing structure, it is a overhead on the system. In that case, I can drop the existing indexing structures, or after observing the application for some time, you may come to understand that some new indexes on some attributes are required, but actually which is not there or which is not constructed during the initial physical database design. That means we need to build new indexing structures. That may also be required. We may also need to drop indexes on files that undergo heavy changes. Initially, you might have done your physical database design assuming that a file for the given relation is static in nature. Later, it turns out to be dynamic, and then hence you may change your decision on that particular file. That is, you may drop the indexing structure on that particular file, because if you construct indexing structures on the files which are more dynamic in nature, and the modifications that are required for the indexing structures, they require a lot of time. Hence, that may affect the performance. Hence, we may take a decision to drop certain indexing structures which are already built, which were static in the beginning, and then later they turn out to be dynamic in nature. That is about tuning the indexes. Then we may also revise our decisions with respect to the database design. And the one important point to be understood here is the denormalization. What do we mean by the normalization process? Normalization is the process of analyzing the effectiveness or the properties of a given relation with respect to keys and the functional dependencies. And what we do is we perform normalization to take the given database or the relation to the required normal form level by applying decomposition. That is, the whole purpose of normalization in database design is to eliminate redundancy. That means to maintain consistency. Okay, when there is redundancy, it leads to inconsistency. Hence, we want to eliminate redundancy by doing normalization. We have already understood what is second normal form, what is third, what is BCNF and all these things, and normally people go up to BCNF normal form. So the basic purpose of this normalization is to eliminate redundancy. Let us take a simple example to understand this denormalization process. Now let us consider this example to understand what is denormalization, and we assume that we have employee relation and department relation where we need to store the details pertaining to these concepts. Employee, we store employee ID, employee name, salary, address, age. Departments, we store department number, D name, location, budget, and then contact for the department. Okay, and we capture the relationship between the employee and then department. That means every employee works with exactly one department. That means given employee ID, which is unique, that is key of this employee relation, can determine the department number in the design. Okay, if we put all employee and then department attributes in one single relation, it violates third normal form, because if I have employee ID, employee name, salary, address, age, D number, D name, location, budget, contact, all these attributes in one single relation, employee ID is the key of the relation, okay, and D number, it determines all the attributes. Employee ID can determine all attributes like D name, D location, D number, E name, everything. But in that single relation, D number, which is not a key, can determine D name, D location, budget and contact for the department. Hence, a non-key attribute determines some other non-key attributes. So it is a transitive dependency exists there. Hence, it violates third normal form condition. To bring it to the third normal form, what we do is we perform decomposition where we put employee ID, which is the key, employee name, salary, address and age in one relation, and department number, which is the key of this relation, D name, location, budget and contact in other relation. And of course, the join condition, that is a foreign key. DNO is a foreign key because every employee works with one department, and then DNO is the foreign key in employee table which points to D number of the department table. So that forms the basis for joining tuples which are spread across employee and department table. Okay, this is normalization. From 2NF I brought it to 3NF. Okay, now with this assumption, we have done our logical database design and we have completed our database design, and then the application was deployed, and then later after observing for some time we understood that there is a query which requires get the employee ID, employee name, department name and then department location for employees where the employee ID is so and so. That means if the employee ID is given, I need to retrieve employee ID, employee name, D name and then D location. And this particular query, to execute this, if the details of employee and then department are available in two different tables, then for every employee tuple where the employee ID is given, I need to search for the corresponding department tuple in the department table and then pick up D name and D location, and I need to project on employee ID, employee name, D name and then D location. That is, every time I need to perform joining operation on tuples from employee to department. And if this particular query is executed quite frequently by an application, okay, that is a quite huge number of times in a given time period, then every time this joining is required, hence this may deteriorate the performance. Now, as a part of this database tuning activity, I can take a decision that I can compromise on the redundancy, but I want better throughput. Then what I can do? Because for every given employee, I also require department and department name and location. So what I can do is, I can redundantly store the department name and then department location information for every employee in the employee table itself. Okay, that means apart from this DNO, I will also store D name attribute and then D location attribute in employee relation itself. Of course, in that case, what I am doing? I am compromising on the quality with respect to redundancy. That is, I am inducing a good amount of redundancy, but one advantage, it is a trade-off. I am increasing the redundancy, yes, I can live with that, but I want a better throughput or the performance. Now, when I execute this kind of queries a number of times, I don't have to access two different tables, and every time I can directly go to employee table and then get employee ID, employee name, and the corresponding department name, and then location from single table. This will definitely increase the performance significantly. So this process is inducing some redundancy into the design. That is, the process of adding certain redundant attributes to the relation wherein I am compromising on the normal form, compromising on the redundancy with an intention to increase the throughput is known as the denormalization process. And for certain applications, of course, this denormalization is very much essential to increase the performance in a significant way. Okay, there is a trade-off. And the last point in tuning options is tuning queries. That means you have constructed indexes, that is the access paths. Now, many database management systems, they provide facilities so that you can specify the system to make use of the indexes that are built on the attributes. That means you can direct the system to effectively make use of the indexing structures available. So this is called as the tuning queries. So the tuning approaches or options involve tuning the indexes, tuning the database design, that is denormalization, and then partitioning. If we talk about the partitioning, sometimes what happens is, suppose there is a company which contains employee records in employee table and which contains huge number of employee records, and the locations, the work locations are different places, that is Mumbai, Delhi and Chennai, and the systems applications which are running at Chennai, they are concerned with only the employee tuples where the employee is working in Chennai, and the application running at Delhi, it is concerned with the employee tuples where the employee is working with only Delhi. So in that case, what we can do is we can partition them. We can put all, that is in decentralized systems, that is in distributed systems, and even in centralized systems also, what we can do is we can put all related tuples at one place. We can partition them. That is, if the queries are quite frequently accessing the employees based on the department numbers, then we can put all similar kind of employees who are working with the same department in one partition, so that the scanning cost becomes less and then the performance can increase. And of course, in distributed database systems, we can partition the tuples, okay, based on certain criteria and put them or place them at a different locations where the applications will access these partitions, okay, and which will increase the performance. And this partitioning can be used both in decentralized and centralized database systems. In centralized database systems, it happens on only one database system, but we will put the tuples which match a particular condition at one place. Okay, so that will increase the effectiveness or the performance or throughput of the system. And the last option is tuning queries. That also we understood. That is, we can ask the system to make use of the indexing structures to execute the queries in an effective way. At the end of this, let us look at the summary of this discussion. We have seen what is database tuning activity and what is its significance, how tuning can be done, and what is database tuning the database design, that is denormalization and partitioning on indexing, and tuning indexing structures. Specifically, we discussed more on tuning indexing structures and how we can revise our decisions on indexing structures which we have made during initial physical database design process. Okay, thank you very much.